My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about color models. So, what are the color models and how it is related to the image processing and how many types of color models and how we are creating the color models we will discuss today. Actually, the color models are the human visual system can distinguish hundreds of thousands of different color shades and intensities, but only around 100 shades of gray. So, color combinations means some, more than more than two colors we are combining, we are creating another color. So, here human visual system is important. How they are identifying the color. So, we are creating as a total 7 colors or visual system as per human visual. So, it can be distinguished hundreds of thousands of different color shades and intensities, but only around 100 shades of gray. Gray means black and white. So, except black and white, we are creating another, that is the colors. So, therefore, in an image, a great deal of extra information may be contained in the color, and the extra information can then be used to simplify image analysis. Example, object identification and extraction based on color. So, there are 3 independent quantities are used to describe any particular color. The hue is determined by the dominant wavelength. Visible color occur between about 400 nanometers violet and 700 nanometers red on the electromagnetic spectrum. So, in an image, a great deal of extra information may be contained of the color. The extra information, what is the extra information from the image we are getting? That is a analysis of the image. Example, object identification and extraction based on color. And 3 independent quantities are used to describe any particular color. The hue is determined by the dominant wavelength. So, how much wavelength we need for the visible of the color? That is a 400 nanometers, that is a violet, and 700 nanometers, it is a maximum wavelength, that is a red in color. So, these are under electromagnetic spectrum. So, it is one example of block diagram of color images. Those are the visible system. So, it is starting from 400 nanometers and ending with 700 nanometers. So, how many colors are there? Here I am taking blue, green and red. So, what is the range of blue? It is a 400 nanometers. And what is the range? It is between the 500 to 600. That is a green. And between the 600 to 700, that is the red. So, shortest wavelength to longest wavelength. So, what are the shortest wavelengths and what are the longest wavelengths? So, gamma rays, that is a 10 power minus 3 nanometers, and X-rays 10 power minus 1, and ultraviolet, that is a 10 power 4 nanometers. These are the visible spectrum. So, what are the visible spectrum means? Blue, green, red. These are the visible system. And longer wavelengths. What are the longer wavelengths means? Infrared. That is a 10 cube nanometers. And radio waves 10 power 9 to 10 power 13 nanometers. These are the longer wavelength. Means visible, high visible system. And the shorter wavelength means low visible system. That is a gamma rays 10 power minus 3. And X-rays 10 power minus 1. Ultraviolet 10 power 1 nanometer. These are the shortest wavelength to longest wavelength with the ranges of color visible system. And color spaces are different types of color modes used in image processing and signals and system for various purposes. Some of the common color spaces are RGB, red, green, blue, and CMYK, HSV, and YIQ. So, these are the 4 types of color systems are used in color models. So, there are different types of color models, but mostly various purposes for different purposes of different signals we are using. That is a common color spaces are RGB, CMYK, HSV and YIQ. So, each one we will discuss. Achromatic versus chromatic. What is a achromatic and chromatic? Achromatic means void of color. Only attribute is its intensity measured by gray levels. Example, black and white. That is a TV. Example, I am taking black and white TV. The kind of images that we discussed. So, chromatic means the wavelength is 400 to 700 nanometers. There are three basic quantities are used to describe the quality of a chromatic light source. Radiance, total amount of energy that flows from the light source in watts. So, achromatic light and chromatic. So, what are the differences and what are the applications? Where we are using this achromatic and chromatic means achromatic is void of colors, only attributes in intensity measured by gray levels. Example, black and white TV. So, in the black and white TV, what are the majority colors? Black and white are the majority colors. So, the kind of images that we discussed. But chromatic means the wavelength is 400 to 700 nanometers. What are the 400 to 700? Red, green and blue. So, in the previous we discussed what are the means? Red, green, blue. So, blue is 400 to 500 and green is a 500 to 600 and red is a 700. So in this range we are calling as a blue, green, red, 400 to 700 range. So these ranges we are calling as a chromatic. So here also chromatic light means 400 to 700 means red, green, blue colors are the chromatic. So remaining means achromatic, that means black and white. So three basic quantities are used to describe the quality of the chromatic light source. That is the radiance, total amount of energy that flows from the light source in watts, and luminance, amount of energy an observer perceived from a light source in luminous LM. That is, example I am taking, far infrared light has large radiance, but an observer would hardly perceive it. Brightness, similar to the achromatic notion of intensity, one of the key factors is describing color sensation. But here, luminance, what is the luminance means? Amount of energy an observer perceives from a light source of the luminance. Example, far infrared light has large radiance, but an observer would hardly perceive it. And what is a brightness? Similar to the achromatic notion of intensity, one of the key factors is the describing color sensation. Here I am taking here achromatic means black and white. Here chromatic means here I am taking red, green, blue, 700 to 400 range. But here what is they are telling that luminance and brightness. So brightness is completely depends on achromatic and luminance is discussing about the chromatic. So we are taking as it is a luminance. Okay, it is depend on brightness. So brightness is about achromatic and luminance about the chromatic. So what are the primary colors versus secondary colors? So primary colors, red, green, blue, RGB components acting as a primary. So what are the secondary colors? So secondary color means combination of primary colors. Combination of primary colors. Those are called secondary colors. So here secondary colors, magenta, that is R plus B, and cyan, G plus B, yellow, R plus G. So mixing the three primaries to white light. So primary colors basically red, green, blue, RGB. That is the range from 400 nanometers to 700 nanometers. So primary colors are the RGB, red, green, blue. Secondary means combination of primary colors, means R plus B, red plus blue, that is a magenta, and cyan, green plus blue, and yellow, R plus G, red plus green. It is a combination, and mixing the three primaries, that is a white light, is also adding to the primary color. And primary colors versus secondary colors of pigments. Here light, here pigments. So what are the primary colors? Magenta, cyan, yellow. So that is a MCY or CMY. C means cyan, magenta, yellow, CMY. So CMY means cyan, magenta, yellow, observed as a primary colors of light and reflect or transmit the other two. What are the secondary means here? RGB. In the previously RGB is a primary and here CMY is a primary. In this, what are the primary means? Here primary colors of light means RGB are the primary. But here primary colors are the pigments, that is a CMY, cyan, magenta, yellow are the primary colors. So combination of primary colors are the secondary colors, that is a RGB, red, green, blue. So RGB stands for red, green and blue. But what are the RGB models? States that each color image is actually formed of the three different images: red image, blue image and black image. But a normal grayscale image can be defined by only one matrix, but a color image is actually composed of three different matrices. One color image matrix equal to red matrix plus blue matrix plus green matrix, means R G B. So red plus green plus blue, it is a one color image matrix. It is equal to one color image matrix. One color image matrix. So we can see here red, green, blue, red, green, blue. 1, 2, 3. So these are converting to the black and white. So red, green, blue means color is converting to the gray. So color combinations are converting to the gray. And what are the applications of RGB? Red, green, blue. The common applications of RGB models are cathode ray tube (CRT), liquid crystal display (LCD), and plasma display or LED display, such as a television. A computer monitor or a large scale screen are also under RGB. So red, green, blue combination where we are using means in the television screen and LCD screen, LED screen and CRT screen. So in these screens we are using normally, that is a RGB. These are the applications of RGB. And what are the color combinations? Green, it is equal to 255 intensity level, 255 plus red intensity level is 255, that is equal to yellow. And green 255 intensity level plus blue of 255 intensity level equal to cyan. And red intensity level is 255 plus blue 255 intensity level is equal to magenta. So it is yellow, cyan, magenta. So R plus G equal to Y, G plus B is equal to C, R plus B is equal to M. So RGB is converting to the YCM. It is a CMYK. CMYK. So RGB is converting to the CMYK. So primary is converting to the secondary. So primary colors I am converting to the secondary. How it is possible means, what are the primary here? Red, green, blue. So I am combination of these colors, it is converting to the secondary. So green plus red equal to yellow, green plus blue equal to cyan, red plus blue is equal to magenta. So total red intensity with 255 plus green intensity with 255 plus blue intensity with 255. These are the add of this one is a white. So R plus G plus B is equal to white. So here RGB is to CMYK, primary converting to the secondary, but here R plus G plus B equal to white. So second one is a CMYK. So it is a one of the color model. CMYK, the conversion from RGB to CMY is done using this method. CMYK color model is widely used in printers. It stands for cyan, magenta, yellow and black. It is a subtractive color model. 0 represents the primary color and 1 represents the lightest color. So So 0 equal to primary color, 1 equal to light color. The conversion of RGB to CMY, that is primary to secondary, is done using the method. CMY color models are widely used in printers. So mostly using in the printers, that are the major application of this one. And what is the stand of CMYK is cyan, magenta, yellow and black. So it is a subtractive color model. Here 0 represents the primary color and 1 represents the lightest or light color. And in this model, point 1 1 1 represents the black and 0 0 0 represents the 0 white. So RGB is converting to the CMYK, that is the primary colors are converting to the secondary. 1 1 1 is a black color. Here I am taking 0 0 0 means white. So 1 is a black and 0 is a white color. So here 1 1 1 represents the black, 0 represents the white, and it is a subtractive model. Thus the value is subtracted from 1 to vary from least intense to a most intense color value. And here I am taking one matrix CMY. It is equal to CMY equal to 255, 255, 255. What is 255? Already we discussed here. Intensity values. These are the intensity values. So this intensity value 255 minus RGB. So it is a secondary color. So secondary CMY equal to 255 minus primary. Consider we have in a color image, means we have 3 different arrays, that is red, green, blue. But now if you want to convert it into CMY, here's what we have to do. We have to subtract it by the maximum number of levels, that is the minus 1. So how many number of levels? Minus 1. Each matrix is subtracted and its respective CMY matrix is filled with result. So here 1 minus RGB equal to CMY, that is the so RGB equal to 255 minus CMYK, that is the 1 minus RGB equal to CMY. What is the CMY equal to? 1 minus RGB. So cyan is negative of red, magenta is negative of green, yellow is negative of blue. So you can see here it is a better example how we are adding the 2 color combinations and what are the, after the combining of 2 colors, what is the final color. We can see here it is the cyan, it is the yellow. So cyan plus yellow equal to green. Here the combination of cyan plus green. So here what is here combining means black. So where we are getting means cyan, magenta and yellow. What is the combination means black. Here I am getting it is yellow. So I am getting red here. How I am getting red means magenta and yellow. So magenta and yellow, that is the red color. Here I am getting blue color. How it is possible means, what is the color here? It is a magenta and it is a cyan. So magenta plus cyan equal to blue color. So how many color combinations we are getting means, here I am getting 1, 2, 3 color combinations. That is a blue, magenta plus cyan, it is one color combination. and here green, that is a cyan plus yellow, green, it is a color combination of 2, and here magenta plus yellow equal to red, it is a color combination of 3, but I am getting 4. How it is means, here color combinations of 3 colors, I am getting the black, so it is a 4. So CMYK. Another color model is a HSV. The image consists of 3 channels: hue, saturation and value are the 3 channels. So these are the very important role to finding out the color of the image. These color models does not use primary colors directly. We are not using ever directly. Why? Because primary colors are RGB. But here I am using HSV. So how it is getting means, from the combination of primary colors, I am getting these HSV colors. So what are the applications of HSV means? Hue, saturation and value are the 3 channels to finding out the original image. And hue is a color component. Since the cone represents the HSV model, the hue represents different colors in different angle ranges. HSV model is used in histogram equalization and converting grayscale image to the RGB color image. So HSV model is used in histogram equalization and converting grayscale images to the RGB color images. So these are the advantages or applications of HSV. Here hue is a color component. It represents the HSV model. Hue represents different colors in different angle ranges, and HSV model is used in histogram equalization and converting grayscale images to the RGB. Here I am taking HSV to the hue represents, but here RGB color for the HSV model with the grayscale images. Next one is a YIQ. YIQ is the most widely color model used in television broadcasting. So in the TVs, television broadcasting, we are using YIQ. So what is a YIQ? We will discuss. Y stands for luminance part of IQ standard of chrominance part. In the black and white television, only the luminance part Y was broadcast. Okay. So Y equal to black and white combination of the TV. So Y value is similar to the grayscale. So we know that the grayscale means it is similar to the black and white. The color information is represented as the IQ part. So the existing formula of converting RGB into YIQ and vice versa. RGB means already we know it is a primary. We are converting into the secondary. So primary is converting to the secondary. That it means YIQ. Primary colors are converting to the YIQ. But what happened here? YIQ is a gray levels or gray colors, means black and white combination. So color is converting, color means RGB is converting to the black and white. So color is converting to the black and white. Input is a color and outputs are the black and white. Suppose I have a TV, the TV is a black and white. But what are the inputs means? The channel is giving the color image, but it is converting to the black and white. How it is means, I am using here YIQ. IQ is standard for chrominance part. It is converting to the black and white. That is a grayscale or gray colors. So next one is a YUV. YUV defines a color space in terms of 1 luma Y and 2 chrominance. That is a UV components. Okay. YUV means luma and chroma. So luma and chroma, combination of luma plus chroma. So NTSC, National Television System Committee, and PAL, phase alternating light, and SECAM, sequential color, and AMEMOR, French for sequential color with memory. So these are the NTSC, PAL and SECAM are the following composite color video standards. These are the composite color video standards. Those are the YUV. So YUV is nothing but a luma and chroma, combination of luma and chroma. It is one example of color model. So it is the RGB, but here only black and white. Here only blue plus green. Here green plus red. So here only majority of green and red is there. Here majority of blue and green is there. Here black and white is there. So RGB is converting to the different color combinations. RGB is converting to the different color combinations. That is a color model. And the next one is a YCBCR. YCBCR color model consists of Y. Y means the luma component, and the CBCR are the blue different, red different chroma components. But it is not an absolute color space. It is mainly used for digital systems, and the common applications include JPEG and MPEG compressions. So when I will use it for the compressions. So for this JPEG and MPEG compressions, we are using YCBCR. But here Y is a luma component and CBCR are the blue difference and red difference chroma components. It is not absolute color space, but the mainly used in a digital systems. But the common applications include JPEG and MPEG compressions. YUV is often used as a term of YCBCR. However, they are totally different formats. The main difference between these two is that the former is a analog, while then later it is to the digital. Okay, it is analog to the digital. It is one example of YCBCR. It is a combination of black and white. Here so these are the different color combinations from RGB, red, green, blue to different color combinations. So these are the references. So as per human visual system, what are the color combinations are there? As per human visual system, that is 400 to 700 nanometers. That is a chromatic range. So what are the human visual system colors are? Red, green and blue. Blue is range from 400 to 500 and green is for 500 to 600 nanometers. Red is for us about 700 nanometers. So we are dividing as a shorter wavelength and a longer wavelength. So shorter wavelength is a gamma rays and X-rays and ultraviolet. So what are the visible spectrum is a blue, green and red. These are the visible systems, and the longer wavelengths are infrared and radio waves are the longer wavelengths. So the color spaces are different types of color modes used in image processing and signals and the system for various purposes. Some of the common color spaces are RGB, CMYK, HSV and YIQ. These are the color models, and here we discussed achromatic versus chromatic. So what is means achromatic? Achromatic means black and white. Chromatic means color, that is a RGB, and luminance and brightness. So what are the primary colors and secondary colors? So we are dividing as a primary colors in the form of light and primary colors in the form of pigments. So primary colors in the form of light means red, green, blue, and primary colors of pigments, that is a magenta, cyan and yellow, and secondary colors are red, green and blue. So here color image matrix equal to red matrix plus blue matrix plus green matrix. Here the combination of red, green, blue, but here input is a color, output is a black and white. Here black is there and here white color, here white and black. So here I'm converting the color to the color image is input and output is a grayscale. So what are the applications with? We are using in a computer screen or TV screen, cathode ray tube, LCD screen and LED screen. These are the applications of RGB. So what are the color combinations? Green plus red equal to yellow, green plus blue equal to cyan, red plus blue is equal to magenta, red plus green plus blue equal to white. These are the color combinations of primary to secondary. So another color model is a CMYK. So CMYK is a cyan, magenta, yellow and black. So here 111 represents the black color, 000 represents the white color. So CMY equal to 255 minus RGB. Secondary equal to intensity level of 255 minus primary color. So that is the secondary color. And here each matrix is subtracted and its respective CMYK matrix is filled with result. So 1 minus RGB equal to CMY. Cyan is negative of red, magenta is negative of green, yellow is negative of blue. And HSV, the image consists of 3 channels, hue, saturation and value are 3 channels. These color models does not use primary colors directly and it uses colors in the way humans perceive them. HSV color, when it is represented by a cone, hue is a color combination of component. The cone represents HSV and HSV model is used in histogram equalization and converting grayscale image into the RGB color images. And YIQ is the most widely color model used in television broadcasting. And Y stand for luminance and IQ stand for chrominance. So luminance and chrominance combination is a YIQ. And YUV is a luma and chroma combination. Y is a luma and UV is a chroma. So water application means using in NTSC, PAL and SECOM. YCBCR is a color model of luma and chroma component. These are the list of references. Okay, it is about color model. And in the next topic, pseudo color models we discussed in the next class. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.